Welcome to another session on polynomials. Previously we learned about zeros of the polynomial. We learned about the remainder theorem. Here we take on the factor theorem, and based on the factor theorem we'll be taking a few questions. What does the factor theorem says? I write the factor theorem factor theorem first. It's almost similar to kind of the remainder theorem, kind of an extension of that only. If Px is a given polynomial, be a polynomial of degree again greater than 1, then it cannot be a linear polynomial, what it means, and a being taken as a be any real number such that PA is 0. That means if you substitute the value which is a, then and you find PA to be 0, that means the remainder to be 0, then x minus a is a factor of px. Now what does this mean? Suppose I take up a question. We will be now showing that x minus 3, which is a linear polynomial. I'm sorry, I think I have also made a spell mistake here. Can ignore that. This we are supposed to be proving to be a factor of the polynomial which is given by x cube minus 3x square plus 4x minus 12. If we can replace here as x to be 3 in the given polynomial and the answer we get to be 0, so I'm trying to check if this is a factor, that means x minus 3 is a factor of this polynomial or not, by substituting the values for x as 3 yes, ultimately I'm getting this as a 0, thereby proving x minus 3 to be a factor of the given polynomial. Various applications now we need take up. Without actual division, the question reads as without actual I'm using some short writings to prove that we have to prove that 2x to the power 4 minus 6x to the power 3 plus 3x square plus 3x minus 2, this is exactly divisible by. Had we not learnt about this factor theorem, we would have started directly dividing the two polynomials, but herein we would not do that. Now that means what we will be dividing, we got this as our gx. Now gx can also be written as x square by splitting this middle term, because we need to find the factors of this given gx, thereby giving it as x minus 2 minus 1 x minus 2. So the factors becomes x minus 1 and x minus 2. In order to prove that this given polynomial is divided by gx, it will be sufficient to prove that x minus 1 and x minus 2 are the factors of this given polynomial fx, because this gx has got these factors. So if these factors if these are the factors of the given polynomials, then gx will be the factor for the given polynomial, which I am just expressing it as f. It will be fx. That will be easier for us to now I'm trying to, first we take up x minus 1. So x equals to 1, I substitute in fx, I write f1, and here I will be taking f2. Let's see if the remainder comes to be 0. 1 2 into 1 to the power 4 minus 6 into 1 to the power 3 plus 3 into 1 to the power 2 plus 3 into 1 minus 2. So it is 2 minus 6 plus 3 minus 2. This yes. So x minus 1 is a factor of the given polynomial. X minus 2 also have to be the factor. So I take up this to the power 4 minus 6 to the power 3 plus 3 to the 2 to the power 2 plus 3 2 minus 2. So that's 2 to 4 to 8 to 16 to 32, 48, 4 3s are 12 plus 6 minus 2, 32 minus 48, that's minus 12 plus 12 plus 18. Did I make a mistake? 32 and 4, that is minus 16 plus 12 again plus 4. So it is 12 plus 4, 16. 16 minus 16, 0. So x minus 1, x minus 2, both are the factors of fx, thereby making the gx, x square minus 3x plus 2 a factor of the given polynomial, that is fx. Let's move on to another screen and take up another question. It says find the value of k if x plus 3 is a factor of 3x square plus kx plus 6. That means if I substitute the value of x to be minus 3 in the given polynomial, that should be giving us a 0. As I mean that is giving us 0 because it says it's a factor. So p of minus 3 will be 3 minus 3 square plus k minus 3 plus 6. That is 9 and 27 minus 3k plus 6. So this is, I think, 33 minus 3k. This should be equal to 0 as it is a factor. The remainder is 0. Thereby making 33 is equal to 3k, and 3k 33 by 3 will give us the value of k to be 11. This is one more type of application. Let's now write another question and take that up. For what value of a is 2x cube plus ax square plus 11x plus a plus 3. Now look at the question formation. It is actually the same whatever we did. This is exactly divisible by 2x minus 1. If this means this is exactly dividing the given polynomial fx, that means the remainder should be, when you are applying x to be 1 by 2, is equal to 0. Now equate when you substitute x as 1 by 2 with a 0 and find the value of a as I did in this question. I hope you will be getting it. I can give you the answer for you to check actually here. You'll be getting an a value to be minus 7. I rather take up another question which says if ax cube plus bx square plus x minus 6 has x plus 2 as a factor, and leaves a remainder 4 when divided by x minus 2. Find the values of a and b. First it says x plus 2 is a factor. That means if I substitute x as minus 2, the remainder will be 0, thereby giving me an equation. So I substitute in fx as f minus 2. So it is a x as minus 2 to the power 3, b is remaining as it is, again substituting the x value with a minus 2. So it is 2 to the 4 to 8, which is minus 8a plus 4b minus 2 minus 6. So it is minus 8a. This should be equal to 0 because 8x plus 2 is a factor. So it is minus 8, and if I carry it to the other side, it is 8. Thereby reducing this equation by 4, so it is minus 2a plus b equals 2. And this is one equation. The second one says if this same fx is divided by x plus 2, the remainder is 4. So I will substitute it as 2. So f 2 a 2 to the power 3 plus b 2 to the power 2 plus 2 minus 6. This should be giving us a remainder which is 4. So this should also give me another equation. Maybe this I name as 1. So it is 8a plus 4b minus 4 equals 4. So it is 8a plus 4b equals 8. If I reduce, I'm getting 2a plus b equals 2. So this is second equation. Let us now solve these two equations. I'll take the elimination method of solving it. That looks now easier because thereby it will eliminate, or I can subtract. This is equal to, this is also equal to 0. Oh, so I'm getting a minus 4a equals 0. That means the a value is 0. Now let us substitute this a value in either of these equations. Maybe I take this one, the second one. So thereby substituting a as 0, so b value becomes 2. So we were supposed to find out the values of a and b. A is 0 and b is 2. Hope you followed that and can take up any question on factor theorem. Thank you.